Good morning. This is a joint work with Cristina Blanco-Perez, and we started this project 2 years ago. We wouldn't have been able to do the project without the funding of BITS and SIGA. It's an intensive data collection, so I just wanted to point this out. And big thanks to Jennifer, Caddy, Kelsey, Alex for organizing this. We really appreciate. Let's start. So let me start by explaining you how I ended up working on publication bias, and then I'll get to the paper in a few minutes. So in 2012, I was starting my PhD, and with other PhD students, we were thinking, so I'm an economist, and we're thinking, what would the distribution of p-values look like in top economics journals? And we were thinking, well, you know, if there's no p-hacking, there's no specification searching, so no publication bias, it should look like maybe normal distribution with a fat tail or something like this. And obviously, if you have p-hacking, so you know you play with your data a bit or something like this, maybe it's going to look a bit different. And so we started collecting p-values from top economic journals, and what we ended up is pretty much what we expected. So the distribution, this is the distribution of z-statistics, so t-stats if you want. And you see it looks like a 2-arm shapes. So they're missing, quotation mark, t-stats at around 1.5, and there seems to be, well, this 2-arm shape, so some of the z-stats seems to be more close to 1.96. So maybe, you know, there's some p-hacking going on here. Some people told us, well, you know, it doesn't look too bad, so economics, you know, we're doing a good job. Others seen this and they thought it was terrible. I'm sort of in between these two extreme positions, if you want. But anyway, so that was, so it took a couple of years to publish this. And then I was thinking, so how do we fix this if there's a problem? So I was thinking about solutions. How can we reduce the extent of publication bias? And after a couple of years, I came up with nothing. And I'm an economist, and for me, what was clear is, so let me just make clear, so when I say publication bias, so that we're just all on the same page, I mean many things. I mean selection of significant, so specification searching, p-hacking, but also selection bias by the editors who prefer things, so estimates that reject the null hypothesis. So I'm going to put all these things together, and I'm going to consider this as publication bias. But anyway, so what I was going to is, as an economist, the way I see things is, well, the incentives needs to be aligned. They need to be aligned with the transparent research. So there are incentives to publish, to get tenure, and you need these incentives to be aligned with a more transparent research. And as I said, I didn't come up with like a better way to make things more transparent. Over this time period, obviously, there was new practices, and at the end of PhD, something came up, and this is what ended up being the paper. So I'm a health economist, among other things. And in February, so early 2015, if you're a health economist, you started receiving a bunch of emails. And in these emails, there was an editorial statement from the editors of 8 health economics journals. So pretty much all the health economics journals. And in this statement, which was quite popular, it was on Twitter, there was support on blogs and things like this. So I'll show you an abstract of the statement. Basically, the statement, what it says is, what we care about is the quality of paper. We don't really care whether, well, conditional on quality. We don't really care about whether you reject or not the null hypothesis. Okay? So they just sent an email to all the health economists telling them this. And, you know, there's support to this. And what we're going to test today in this paper is just, as this editorial statement decrease the extent of publication bias in health economics. So we're going to collect data before and after the statement and try to see whether the shape of the distribution of published article change after the statement. Okay? So the editors of these 8 health economics journals, what they wrote in the statement is that they believe that well-designed, well-executed empirical studies that address interesting and important problems in health economics, use appropriate data in a sound and creative manner, and deploy innovative conceptual and methodological approaches compatible with each journal's emphasis and scope, have potential scientific and publication merit, regardless of whether the studies reject or not the null hypothesis. Okay? So this statement is still on the journal's website, and they actually also remind referees each time you refer a paper for these journals, of the statement. So the letter that you receive as a referee, there's going to be a link to the statement. And they also say this in the statement. So moreover, we believe that this statement should reduce the incentives to engage in two forms of behavior that we feel ought to be discouraged in the spirit of scientific advancements. Authors withholding from submissions studies that are otherwise meritorious, but whose findings are highly likely negative. So basically that the null hypothesis is not rejected. And then also reducing p-hacking, specification searching, and so on. So the editors, what they have in mind is trying to reduce the extent of publication bias and trying to encourage authors to submit papers that they would not have before if you do not reject the hypothesis, or trying to decrease the extent of p-hacking. But also they want to change the behavior of referees, as I said. So when we think about how the statement could affect incentives and behaviors of people, well, there's three types of agents in this study. So there are the researchers themselves, the authors. So you receive this statement, and all of a sudden what you're thinking is, well, you know, I have this paper that does not really reject the null hypothesis. I was thinking to scrap it, and now maybe I'm going to submit it to these journals. Maybe the likelihood that the paper get accepted is higher with this statement. Or maybe you just decrease the extent of specification searching, p-hacking that you're doing in your paper because you're thinking, well, you know, maybe they don't really care whether it's significant at the 12% level or 9% level. It's all the same to them now. So it sort of changed your perception maybe of this. And so maybe this is a long shot, but maybe you're more likely to start working on projects that are more risky. So this would be more in the long run. So you're thinking, well, you know, this project is probably not going, we're not going to find any effect of that policy. And before you would not have started the project, and then maybe now you're starting to start this project. As I said, the referees, so the second group of agents that could be affected, the referees are reminded of the statement, but also if you're a referee, maybe you just realized or your perception of the extent of publication bias goes up. So maybe you were thinking, wow, you know, there's a lot of publication bias in health economics. Now they remind me of this in the letter for doing the referee. So maybe perception of the extent of publication bias changes. So, you know, referees' behavior could also be affected by this. And then there's the editors themselves. The editors clearly before the statement or at the moment of the statement, they already had in mind to accept more of these studies. So it's going to be a bit more tricky to actually figure out the causal effect of this statement. So their preferences are arguably changing. And so what we did in addition to collect all the data I'm going to show you is actually to talk to some of these co-editors. So why did you start this project? But also more interestingly, so they didn't collect data. They didn't know we were doing this study, by the way. So I showed them the results like recently and asked them a couple of questions. So it's not based on our data, but the editors said that they started receiving more papers not rejecting the null hypothesis, for instance. It's just speculation, but you'll see that it sort of fits with the results that we're going to get. So what do? We collect coefficient standard errors for the papers published in 2 of the health economics journals. So we do not do the 8 journals. We only going to focus on health economics and Journal of Health Economics. They're more general. They're the, you could say, top tier in health economics. And the other journals, sometimes they don't really publish papers that actually run regressions, or the sample size is going to be very small, so we exclude them for these reasons. Also, they don't put papers that are forthcoming on the websites, so our sample size was really, really small with the other ones. So then we will focus on 2 journals. And what we do, we categorize papers in 3 categories. Before the statement, so that's going to be a paper submitted and published before the statement, so before 2015. And then there's this category, a bit weird, which we call during. So the paper is submitted before the statement, but it's published after. And we're going to argue that if there's an effect during, so if we see a shift in the distribution during that period, it has to be that the editor's preferences change. It cannot be the authors or referees because you submitted the paper before the statement. And then we have the other category, which is you submitted the paper after 2015 and it got published afterward. In this category, we're going to argue that, well, it's an assumption, but that the editor's preferences between during and after didn't really change. So if we see an effect for after, it's probably related to referees and authors' behavior. I'll say more about this in a minute. And then we did pre-analysis plan, and we have a control journal. It's a similar journal, similar impact factor. Health economists typically might publish 1 paper or 2 papers in this journal during their career. So if we look at the resumes of these people, it's a journal that sort of makes sense, that is quite similar, but it's not health economics, so it's not affected by it. So it's a control journal to do a diff and diff. I'll come back to this. So we collect Z-stat. And also we're going, so how do we do it? We look at the paper, we look at all the tables presenting the main results. We exclude any tables that report robustness checks. So in the text or in the title table of the report, well, you know, this is robustness checks or something like this, we do not collect this. We exclude first stage, we exclude placebo tests, we exclude the matching, so things like this. So we're going to focus mainly on the main tables of the paper, okay? And then we look at the type of papers it is. So is there a theoretical model? Which type of methods they use to control for some of these things? So maybe the statement changed the type of paper that is published. They're trying to control a bit for this. And also the characteristics of the authors. So the gender, whether they're tenured, whether they're at the top institution, whether they're published in top journals, etc. So trying to control for some characteristics. So what we get is something like 12,000 tests. So 12,000 p-values, about half of the p-values are from health economics, the other half from JHE, so Journal of Health Economics. And for the control journal, we have about 2,500 Z-statistics. As you can see, most of the articles are for JHE, but these articles usually have less tests. And for health economics, we're talking about something like 60 articles in our sample size. So that's a distribution of p-values, or z-statistics, I should say, before the statement in the 2 treated journals. So for health economics and Journal of Health Economics. So that's what it looks like. And what we're going to be interested in is what happens after the statement. Is there a shift to the left? So if you expect that people are now publishing papers, that papers published are less likely to reject the null hypothesis, you would expect a shift to the left. And if there's no effect, well, you would expect that the distribution would be pretty much the same afterward. And this is what we find. So you see this big shift, well, quite big shift. I'll show you some numbers later, to the left. So let me go back to before. So you see that something like, so in terms of if it's significant at the 5% level, there's a shift of 5-6% in terms of shifting to the left. So the likelihood that you reject the null hypothesis decreased by something like 6-7%, okay, from before to after. I'll say a bit more later on about whether this is a lot or what does that mean. But anyway, so this is the main result of the paper. The rest is just putting more controls and trying to convince you that this is a causal effect. So before the statement, 49% of tests were significant at the 1% level, or 61% were significant at the 10% level. That's very similar to the first picture I showed you. So, so what we did a couple of years ago was to collect for top economics journals. It's very similar. So the shape of top economics journals in terms of like the number, the share of tests that are significant is quite similar for health economics before the statement. And afterward, what you see is the shift to the left. And to give you an idea of whether this is a lot or not, whether this is a big effect, one thing you can do is to to compare the distribution of z-stats in these journals to a distribution where you would think there's less p-hacking. So if you look at RCTs in economics, usually the distribution of p-values or z-stats is looking a bit like a normal. So there seems to be less p-hacking, at least in econ for field work. You see that 41% of tests for RCTs are significant at the 1% level in top journals. So that's much less. So maybe the statement is moving the distribution to the left, but maybe there's still a lot of work to do trying to get to this whatever benchmark. So just to give you some numbers, so that's so just pick one row and maybe stick to it. It's going to be a bit easier. So what you have here is the share of tests that are significant at the 1% level, 5% or 10%. So let's take 5% for instance. So what you find is 50% of tests were significant at the 5% level. So that's the first column. This is before the statement. It goes down to 52 during, and then after it goes down to 49%. So this is for 5% level. And then the last three columns, column number 4, 5, and 6, what they do is just look at whether there's a significant decrease in the share of significant tests. I don't know if that makes sense. So what you have in column number 4 is before in comparison to during. So it's a decrease of 3%, for instance. Or number 5 is a difference between before and after, etc. Okay? So what we're going to do is looking at this, putting this in a framework with a regression, and also doing a similar exercise for the control journal. The control journal was pre-specified, and actually what we find with the control journal is completely the opposite. The share of significant tests just goes up by a lot. And what we were thinking, so we chose the journal because it's a, as I said, it's a journal that people can, health economists can also publish in this. The impact factor is really similar and so on. And what we had in mind is either it goes down also, so we're going to underestimate the effect, or it goes up like this. If it goes down, maybe it's because we're living in a world where now we're a bit more transparent. And if it goes up, maybe it's because there's more and more pressure to publish in top journals and people are doing more and more p-hacking. So anyway, either you look at just the first difference, so before and after the editorial statement for treated journals, or if you're interested also in looking at, using the diff and diff with the control journals, then we're underestimating the effect with just a first difference. So we're going to do the diff and diff. So we're going to have an outcome variable. So it's the share. So it's whether a test I in article A, and then in a journal J at time T, whether the test is significant or not at the 5%, 10%, or 50% level, so whatever significance level you want to look at. We're going to have this dummy variable, which is during or after versus before. And then we're going to have whether it's a treated journal or not as a second variable. And then the interaction of these two variables gives us the effect of the editorial statement, so the diff and diff. So the coefficient of interest, so what I'm going to show you is, what we're going to focus on is gamma. So just whether it's significant or not, whether there's this decrease. So basically what I've shown you before, that there's this shift to the left. And we're going to control for the type of paper, so GEL codes, whether it's theoretical models, whether it's single author to multiple authors, ratio of female authors, ratio of authors at top institution, as I said, etc. So trying to look at whether there was, so showing you just the results without any controls, and then trying to control for some things that could explain why we find this effect. Maybe it has nothing to do with the statement, maybe it's related to some shift, or the papers are somewhat different afterwards, so something like this. So what you want to look at is the third row. It's going to be the coefficient of interest. In the second column, there's no control, so that's pretty much what I showed you before. So there's a decrease of 23%. It's huge because now we're doing the treated before and after, but also the control. And you see that the control, it went up by a lot. So the combination of the two becomes really big. So we're finding an effect of a decrease by 23% of whether the tests are significant at the 5% level or not. And when you start putting in control, so authors' characteristics, articles, and so on, it doesn't change. It doesn't change much. The coefficient is pretty stable, and in terms of like whether it's a big effect or whether it's significant or not, it really doesn't explain much. Some people also suggested that we control for the number of citations of this paper, trying to control for quality. I think it's a bit endogenous, but we don't find any effect actually on impact factors. I'll come back to this a bit later. But anyway, it doesn't change anything. Yeah. So you might be thinking, okay, so there's this result, but maybe it's related to many different things. Maybe it's the way we collected the data. So you can put different weights on the different tests. So for instance, maybe some papers have a lot of, so imagine you have a paper that rejects the null hypothesis. Maybe it has more tables and more coefficients, and we're just capturing this. So you can put the same weight on every article, or same weight within a paper, the same weight on each table. It really doesn't matter. It doesn't change anything. Also, the shape really is the same. You can just look, so we find an effect for both journals, so you can omit one of the treated journal or the other one, so HE or JHE, doesn't really matter. You can focus only on one table per paper, so some people said this, so maybe we're collecting too much information, let's just focus on a subset, it really doesn't matter. Actually, the coefficient goes up. So what we find is this shift to the left. It's robust to a number of things. Some of the papers actually were published by the co-editors themselves and the editors, so we removed them because we felt like, yeah, the statement is working because you're publishing in your own journal. Maybe that's not really transparent. So anyway, we omit this small portion of papers that were published by the editors themselves. And what we did also is to look at the trends. So if you focus only on the treated journal, and you look at the effect from before to actually even before that, so a year before, there's no effect. There was nothing going on. It's really when the editorial statements kicked in that there's a shift to the left. And then some things that were not pre-specified, we find that most of the effect is coming from multi-authored articles and researchers from non-top institutions. So some people were thinking maybe it's a network, maybe it's only people from top institutions that now they publish their papers in these journals that they didn't reject and failed to publish in top journals. It's not really this, actually. Most of the effects is coming from, well, I guess people like me and multi-authors. So if you look at who rejects null hypothesis, single-authored papers are way more likely to reject the null hypothesis usually. And people also from top institutions. So we actually find that most of the effect, thank you, most of the effect is coming from people who are already less likely to reject the null hypothesis. Don't know if that makes sense. So before the statement, some characteristics predict whether you reject the null hypothesis or not in your paper. And the characteristics of the authors or papers that predict that you do not reject the null hypothesis, well, it's this subgroup of articles that actually we find the effect. So people who always reject the null hypothesis, like single-authored papers, we don't really see a change for these. Anyway, we just came up with this result, not really sure. We're still thinking a bit about it. It was not pre-registered. So. And now what I want to look at is after versus during. So trying to figure out whether all the effects that we're capturing is because the editor's preferences were changing. So you could think that some of the effect was during. So what I did before, what I showed you was during and after together versus before. Now I'm just doing the after versus during, okay? And what you find is that most of the, so there's an effect, there's a decrease, a shift to the left, but it's coming only from one journal. So we find that for Journal of Health Economics, there's a shift to the left, but for Health Economics, there doesn't seem, it seems to be all driven by the editors themselves. So there seems to be, an effect on authors and referees' behavior, but it's coming only from one of the journal. So let me conclude, and then I can take a bit more questions. I've got a few minutes left. So the statement shifted to the left, the distribution of tests. We find a part of the decrease is due to the editors themselves, that just they accept now more papers that do not reject the null hypothesis. But there seems also to be an effect on referees or authors when able to disentangle which one of the two groups. So at least for one of the journal, we find this. And we think this is, it's really easy. It's low cost. You just send an email to people telling them like, we don't care whether you reject or not the null hypothesis. We care about what conditional on quality. What we care about is we just want good papers. And many other journals in different social science or even hard science could do something very similar to this. It's low cost, it's simple, and some people pointed out it's a bit like the badges in psychology. It's a bit different. One is more about sort of reputation, so you want to put your data online on the website of the journal, whereas this is more trying to affect a bit the incentives to publish. But anyway, these are really low cost, simple methods trying to make things a bit more transparent. And as I said, we don't find any effect on the impact factor. So as editors, maybe it's something that they want to consider. Obviously here, one thing just to conclude is almost all the, so there was 8 health economics journals who did this. I think it's really important. If it's only one of them, maybe the results are very different. So it's something to keep in mind. Maybe it would have been worse, maybe it would have been better. It's only speculation, but I think it's important keeping this in mind that it's a subfield of economics entirely that decided to put in place this basic editorial statement. Okay, so looking forward for your questions and comments. Yes, please.
I have a couple of questions. Thanks for that. So like 3 questions. First is, can you tell us what the control journal was or not?
It's either something like JHR, JPUB, or something like that.
Something in that level?
Yeah.
Okay.
Something like that.
Okay, that's great. Second,
Does that make sense?
Well, that makes perfect sense, actually.
Okay.
I was going to say JHR would be the perfect
Yeah, well,
comparison.
could be. Maybe it's not. Yeah. I don't know.
So that's great. The second point is, I think the non-effect on impact factor is a very important finding, because I think the concern of
I see. So I was talking to Eva Vivald, and she said to look at number of submissions too. So maybe, you know, there's no effect because they just receive more submissions. I think it's something,
It's
you
possible.
know, it could.
That would be an interesting
Yeah.
one. The third point, which sort of relates to the first question, is are you concerned, and maybe it's not so much a concern because you had 8 journals going together, but are you concerned that there was some substitution? So even within the same author, so you wouldn't see it in the author characteristics. They have their kind of null effect paper and their strong effect paper, and now there's just sorting. Now I sent my null effect paper to Journal of Health Economics and my sexier paper to Journal of Human Resources. And so I'd almost want you to look at like the full pool of health economics papers published
I know.
before and after and see if there's sort of a system-wide effect. Or is that
Well, you know, if you keep giving us money, we might do it. So for, you know, for the control journal, whatever that journal is, we exclude the health economics paper. So, you know, the big shift to the right is not explained by them shifting to this. At least it could be, but it's not in our sample. And so what we could do is for these, you know, sort of other journals with the same impact factor to collect the health economics papers. But there's no way we can collect like all the, or from similar authors, maybe that would be easier. So similar author publishing a paper, a health economics paper in another journal during that time period or something like this, or subgroup of authors. This would be more feasible and less ambitious maybe, but that's very useful. Head, please.
Yeah, I have a question about whether p-hacking is a good thing or a bad thing. And I have this feeling that in psychology, stepwise regression is the tool of choice. And what that does is, depending upon the cutoff rule, is going to concentrate the data evidence on a smaller set of parameters. A good thing.
So, you know, I think that's a good comment. And I'm sort of moving towards this idea more and more. I use not to, but, and you know, it's a bit different, but somebody once told me, you know, publishing is a bit like dating. So on your first date, you know, you look nice, you put perfume or whatever. And the referees, they know this, they're not stupid. So it's a stackable strategy and you just discount this a bit and it's sort of implicit. I don't know if p-hacking is that bad in economics or, for many reasons, I think more and more I'm thinking, and it's, you know, you'll see the next presentation too, maybe it's not that bad at all. But here, you know, I don't know if it's p-hacking or it's also that some papers would never have been published without p-hacking or not, and then they get published, which is different. So I'm not able to disentangle these two things. So I think it's a really good comment. Anyway, thank you.